I've mostly talked to each and every person here in the room, so mostly you guys are already aware about what is Connext. And simply explaining, we have been here in this space for 3 years. We have been focusing on interoperabilities, and we have built like multiple projects, starting with Sanchay, Vector, Indra, and before this, the project we did was Vector, and we hit 500 million volume in it, but we were using state channels, so we hit a limitation of the scalability in it because we have to basically maintain a same DB at all the nodes which are getting created. So that means each and every user. We realized this problem and we started doing interchain. That is Nxtp v0. Where we started, and we realized that also that right now with the current stuff which is running, which is supported for 15 chains and more, the only problem which is coming in right now is the segmentation of the liquidity, because the way it works is that when you put your funds on the sending chain, people receive funds on the receiving side. So assuming that there is a lot of users coming onto this specific sending chain, then the liquidity gets collected over there. So now what we did is that we have been working for like 6 months to produce this new solution, which is called Amarok. You have seen our swags, which have a wolf kind of figure, and that animal is known as Amarok. So we are calling this hard fork and Amarok. And we are collaborating with Nomad, which is a messaging layer cross-chain, which is a slow one. It is based and inspired from Rollup. So it takes around half to 1 hour to provide and prove that this message which is coming from the sending chain is true. Would love to deep dive into how this works, technically Nomad itself, and how Connext is working. But we'll start with the basics. What has been with the Connext, what we have been building until now. Starting with my introduction, I'm a project manager and engineer at Connext, more or less like engineer, which got a lot. And we have been a trendsetter. We have been a thought leader into this ecosystem. So we want to make sure that everything is crystal clear to the people who are coming to this ecosystem, and naming it because there are multiple chains which have maybe chain ID or not, or which have their own ecosystem, which have their own VMs, or maybe no VMs like Mina. So we want to make sure that we can be interoperable. We can be with any chains which are coming in live, and that's why we are naming any sort of domain from which one chain to another, or a domain to domain you can connect, and it could be L1, L2, side chain, or non-EVM. So it could be Near, Optimism, Polygon, Ethereum itself. So we are calling these domain. These are the execution environment where you can run your a cross-chain application and connect it with the other one on the side, on the other chain. That is going to be a domain. And we are calling these applications not app, not dApp. We are calling them Zap, because they are cross-domain communication. So we can do a native application integration with cross-domain. So any chain we are calling cross-domain, we are calling is cross-domain native dApp. So that is Zap. Not going to take much time off now, but going to quickly skim through all the slides. Why Zaps? Because we have seen interoperability problems coming in last 5 years. We have seen why we needed ETH2, and then there are multiple chain coming. But now how the liquidity segmentation, bridge hacking, and all these things are coming in. So we want to make sure that when you are using or building a domain Zap, that time you make sure that there is a significant security available onto your bridge. You are not making a trust assumption, and you are making a winning L1, L2 dApp, which can be used by a user. So user want to use any app, any chains right now. So you want to make sure that your application is available with them. And there are maxis which maybe are more favorable to ETH or Polygon, Near, I don't know, Scalar, Mina, and there are many apps. But we want to make sure that you are with the user. So you want to build an app which is available to all the users, all the chains, so you can have more users into your ecosystem. Onboarding user is very easy. If you are an ETH, it's going to be very hard because it's very you have to pay a high, they have to pay a high fee. So it's better to avail it on multiple chains so they can come from anywhere. Again, security is very important. We have seen a lot of bridge hacking in last year, and why it is important, everyone knows now. And that is what Connext validates now, that security is very important. You want to make sure that whatever you are building is very secure. So we don't do any trust assumption. It's a trust minimization solution, but you want to make sure that on whichever dApp, whichever chain you are deploying, it is secure. So the only only thing which is available to your, which is threatening your app with the security is the chain itself, which is on deploy on. Here, it is going to be a domain. Cross-chain deployments is already here. There are multiple apps which are live. With ours, Lefi, the layer swap. So there are multiple applications which are already building in. Aave is doing their V3 version, which is going to be using natively Nxtp. So it is going to be amazing. How you can improve the xApps. So you want to make sure that the interface which you are using is same to all. So it is easy to actually scale and build, and make sure that it is easy for the user to actually start with something. So you don't want to change things for the user when you are switching with the applications or with the chains or the domains. So you want to make sure that the interface stays the same. The bridge is abstract. It doesn't have many layer of securities involved. So that is why Connext is ideal for you guys. And you can pass call data. So you can call contracts from the receiving side. You can perform multiple things like DAO-to-DAO interaction, metaverse to metaverse. You can build wall apps. You can have so many possibilities and so many use cases. I don't really imagine right now. We are waiting for the developers to come in and actually build some cool shit on us. Thank you very much, sir. And we are trying to support as many as developers as possible. There were a couple of right direction which were taken in controlling the protocol bridge, which were availing a single user who comes in. He doesn't have to know that which chain he is on. He wants whatever the application is built for, they should actually perform that. So if you are talking about xApps, they want to get most APY. They don't really have to know which chain they are on. They simply want to get a benefit out of it. So this is the ideal world where the protocol bridging is coming in. It is more or less, they don't really care. Right now also in Web 2, they don't really care where the data is saved. It should be same, but now they should realize, slowly they are realizing the security aspect of it, but they don't want to move ahead with that. But now if you can have some sort of interface which can allow them to move in a very secure or in a very UX friendly way, that will allow the users to come into and get into the blockchain system, and that is what we are looking for. Challenges. So these were the challenges which we have seen throughout the time, which we were facing for the last years, that deploying the contracts gets very hard because there are multiple chains, so you have to keep a track of it. And managing these deployed address, so whenever you are sharing with the application, it gets complicated with them because on some chains the address are different, on some chain it's not. And reading from the chains, the data which is available from the chains, when you are reading from the subgraph itself, there are a lot of blocks sync. They are not synced to the latest. There could be a 200 blocks delay. So you want to make sure that whenever you are reading the data, you are on the latest. So this is something which we have been solving a problem with the graph itself, and many multiple companies we have been talking to. We have Beurs, where we deployed multiple graphs. So we want to make sure that the data is available all the time. So the piece of infrastructure shouldn't be the failure of your application. So we want to make sure that doesn't happen. So we have like 2 to 3 backups. When you are deploying, you're using a RPC, you don't use a single RPC. You have multiple RPCs which are in there. So these are the things, these are the steps we have taken to make sure that the UX doesn't suffer for the user and your dApp. Building with Connext. So it is quite simple. The one way is that you can do a simple transfer. very simple. You use the SDK, you make a X call, and that is all required. And the user will receive their funds like in 10 to 2 minutes, depending on whatever the chain they are interacting with. So if you are in Polygon, we will wait. So any chain, we simply waiting for the safe confirmation to be happening. We want to make sure that no reorg happens, so router won't lose the money. Otherwise, router can actually take the risk, but more or less, if it is Polygon, I would say 20 seconds is more than enough, where we are making sure that 150 safe confirmation happens, and then the receiving side transaction happens. So in 20 seconds, people are actually moving their money in the most cheapest way possible and the most secure way. So this is the incredible solution we are offering for the dApp developers to actually scale their users. Other than this, we have instant liquidity bridging now because the liquidity will be available. If it is not, then we have a slow liquidity, which will be done in like 30 minutes or so. So there is, if a user is creating a transaction, you are sure that it will be done within 1 hour, and it could be done instantly. It won't. If it doesn't happen, then we will show you that is the slow liquidity. There are parameters where that's how you can check it. Other than this, there are so many possibilities using the call data itself. You can call a DEX where you can make swap. You can call a DAO where you can vote in cross-chain mechanism, where you can move the liquidity from DAO to DAO in the most trustless manner. So these things are possible with Amarok when you build with Connext. Anatomy of xApps. This is something we have been talking about when we are saying that how you can do a contract-to-contract interaction. You can have your origin contract, which can be built upon the Connext, where you will have an X call into it. So you do a contract-to-contract. It doesn't have to be off-chain. You don't really have to use a SDK. Even if you make a direct call to X call, then also it will be picked. So it doesn't require any sort of off-chain piece of infrastructure to be communicated from the user or are required at the part of the part where the dApp is interacting. So you can do a contract-to-contract interaction. You can do a simple SDK call, or you can simply call the contract itself. So any of these are possibility which can happen. So when we are talking about how does this basically work, we have a Connext contract on both the chains. On sending side, you will call xcall, which will provide you will provide the basic data where you are providing the amount or the piece of information you want to deliver, and mention the call data if there is a receiving side call you want to make. This is the only information which is required on the sending chain. This happens, there are routers, one of the key infrastructure in Connext, which are the liquidity provider or the message relayer, I would say. So once router sees that there is a transaction happening on the sending side, so what they do is that they basically compete with each other, and one of the router or a couple of the router who can collectively provide the liquidity or the message, they will send their request, and the relayer will send their transaction on the receiving side. This happens, user receives their information and proceeds with whatever they were doing. In case of permissioned contract, which will be a part of the starter kit, we will tell you about it, which is required in some cases where you want to make sure the origin sender, the sender on the sending side, is the one you want to trust. So in case a DAO-to-DAO interaction, you don't want to trust the user who is creating the X call. You want to make sure the user who's calling the X call is your DAO contract. So you want to make sure that origin sender, which is coming from the sending side, on the receiving chain, that this is the person, this is the contract which called it. So you can have some modifier on the receiving side and have this permissioned way. So this is all you can actually get at the xApps starter link. If you go there, we have three ways to actually start interacting, and we did mention if you go to docs.connext.network, you can you will have a getting started, very simple, where you can do an instant transfer, maybe you just have to download the SDK itself and then just get started with it. I can show it to you guys right now, if you can start and do some coding. If that is cool with you guys. Any question till then, I will take it. Please go ahead, sir.
So I'm kind of new to bridging. So you mentioned that Connext is much more trustless than normal bridges.
Right.
How do you guys make this happen?
Okay, so that would require a couple of comparisons, but I would simply say why we are trustless, because we don't assume any sort of validation, or there is no set of validators who are actually where you are depending your money onto them. The router who are providing their liquidity, they are actually they are making sure that, okay, I'm fine with completing this transaction. So they are not actually giving out the money to any third party. Okay, please validate for me. That is not the case. Router is actually checking that there is a transaction happening on the sending side. They make sure, because they are reading their own data. We are not the one who are providing them that, okay, this happened, please make a transaction. That's not the case. Router have their own key infrastructure where they are making sure that they are reading the correct data, and then they are creating a transaction. And we don't want to race it, so we create a competition and a way where they can actually send the transaction on the receiving side.
So wasn't there... So using this logic, right? So like...
Right.
I'm not too familiar with the technical aspects of how these bridge hacks or the exploits actually function, but like, so these wouldn't be possible with your like trustless system.
Right. So the only trust minimization. So we were trustless until now. We didn't had any sort of trust assumptions. Now we are depending on trust Nomad in this case, where for the relaying of message, that's where we are saying trust minimization. But that is all the risk which will be taken by it will be router. So how this is working with us right now with Amarok upgrade is that once the user is creating their transaction, router creates a transaction on the receiving side, they complete their transaction, that is going perfectly fine. Now how does the router actually receives their money? So basically they wait for the Nomad, which takes around 30 to 1 hour to complete the message sending on the receiving side and receive their money through the slow liquidity path. So we provide the fast interaction for the user, and router will receive the slow one through Nomad. And for that, they will charge 0.05%. And if that is something subject to change, that will be present on the docs. Any other question I can entertain with? Okay, awesome. We can get started with a couple of, I'll just go or do an overview how you can actually get started and build some cool shit. So we have a xApps starter. We have kept it very low level, and we didn't provide any sort of starter, like a UI, which we are not very much interested in. So even if you don't really have a UI, even if you are doing a contract to contract interaction, that is completely fine with us. We want to see the use case that can be possibly happen with you guys and have the potential to build it. So that is the only requirement. We are not looking for any sort of UI. So when I said that you can build some X domain, when I said that you can, what are the possibilities of the use case you can build with? So the very simple one would be like a 10-minute integration or 5-minute integration would be simply download this SDK and then just create, which will be an initiation. And the SDK config consists of chains, like chains where you are mentioning the provider, as well as the addresses of the tokens which are there. And that is all the config which is there, which will be available. We will update the docs better, or you can search the doc, search the SDK requirement itself. Other than this, we have xcall, which is the main function where you will provide whatever you want to transfer from one chain to another. So we'll mention the to address where you want to, the target address where you want to have the interaction to be happening, or the receiver of the funds. Call data will be something, it could be 0x if you are not interacting on any contract on the receiving side. If you are, then the call data will be a function encoded function, which is an interaction which is happening on the receiving side. We can help you with that. We have examples, so nothing to worry about. Origin domain and destination domain. So instead of chain ID, again, we are using domain to make sure that all the chains possibly can be supported. All the chains, L2s, rollups, and non-EVM chains. So we want to make sure that we don't stick to the chain ID standard. So the domains documentation is available right now, and if you have any questions, we are happy to support with it. You mentioned these couple of params, and other than that, you mentioned what is the transiting asset ID. You will mention the asset ID you are transferring from one chain to another. So you will mention that and amount. This is all required, and this simply you call xCall. That is the only thing you require, and you will instantly receive the money on the other side. Right now, the testnet is available on Nxtp and Kovan, so you can test over there. Sorry. Other than this, when you are trying to build some cool things, you can do. Sorry.
Could you repeat the test?
Kovan and Nxtp. Thank you. When we are doing the interaction from contract, so what can you build? You can actually hold a governance vote on one chain and have the interaction happening from multiple chains. So you don't have to actually create the proposal on all the chains, and then you can't you will be combining it, but it's not traditionally decentralized. So you want to make sure that it is decentralized. So you can have the voting done on a very cheap chain, and if a person is there who is not actually working with that specific chain, he can call it from the another chain. So this can happen. You can hold the proposal voting on one chain and have the votes coming from all the chains. So, and the address will stay same, where you can have the validation done, and you will be creating some middleware contracts above the connects to make sure this happens. We can go through the details, but it is going to be the permission one, which is mentioned under the starter kit. So once you go through in the overview, we have mentioned a couple of things where we have permissionless and permission. Here you can have the use cases, as well as we have explained what is the requirement for those contracts to be built. Coming back to all the possible use cases, token bridges, this is NFT bridging, which can be happening. You can create one contract on the sending side where the burn can happen or lock can happen, and on the other side you can mint. So you can this is NFT bridge, which can be done and built using Connext. And other than this, I think we have a hacker who is building the NFT bridge, and it is going to be super cool if we can build it during time. We are really looking forward to it. A swap and a transfer on the receiving chain. So assuming that you want to do a swap on Uniswap or 1inch or any sort of DEX, you can actually provide the call data when you are calling during the X call, and then you can make a transaction on the receiving side. Other than this, we have DEX liquidity, xApps, critical protocol operation, which can happen to make sure that global constants which are there will stay the same. You can build Uni v3 TWAP, which is very exciting. You can have chain agnostic V token governance, which will be soon done by Aave, but would love to see one of you building that. And metaverse to metaverse interoperability. This is very strong. So these can happen all. If you go through, we have put in some examples, possibly in the starter kits, where you can see that what are the requirements. If you have to go through the permission layer, or if you have to go the permissionless. If you are going with permissioned layer, then you will have to use the slow liquidity. There is no possibility to use the fast one, because you want to make sure the origin sender, which is coming from the sending side, is the one which is your contract. In fast liquidity permissionless, the fast interaction is possible. So these are some of the examples which you can go through the documents. And if you have any question, we'll be here all day tomorrow too. So yeah. Thank you. I think I will conclude here. Thank you so much. Yeah. Any question if you have? Good. Thank you very much.